Alright, these are 8C notes. And for 8C, we are solving rational equations. So example 1. So I'm going to write the steps for every single rational equation, not just example 1. But our step number 1 is to factor the denominators, factor all of the denominator. If possible. So that's not possible for everyone. If we're looking at our denominators for number 1, those are all monomial denominators. They are already factored. If you really want to break down the x squared into x times x, you're more than welcome to. No harm in that at all. That way you can kind of see which each denominator has factor-wise it broken all the way down. You don't have to do that though. Step 2 is to get common denominators. So to get common denominators, we need to look at what do we already have in common with each denominator and what do we not. So we see we have 3's already in common with all of them. All the 3's are in common, so our coefficients, all that's good, that's common. We also have an x in all 3. What we do not have is we do not have an x or 2 x's in all 3. Well, that means that we need to get common denominators, we need to multiply that last denominator by x. So we're going to multiply the denominator by x. But by doing this, that changes the value of the problem. And we cannot just multiply a denominator by x. With multiplication, we need to either multiply every single term by x, which if we do that, that's not going to then our other denominators would be different. If we multiplied every denominator by x, then it wouldn't be common. Or you can multiply by something that's equivalent to 1 to any term. And that's what we're going to use here. We're going to multiply by x over x. That's equal to 1. By multiplying by 1, something that's equal to 1, it does not change the value of the problem. So that's very important here. It doesn't change. It's still an equation. It's still equal. Well, left side still equals right side because I multiplied by something that's equivalent to 1 to the 2 over 3x term. Now I'm going to quickly rewrite what we have just to kind of see. So I have x minus 4 over 3x squared plus 1 over 3x squared equals 2 times x, or just 2x, over 3x squared. So we have like denominators here. Awesome. All the same. The next step, pretty simple step, is to drop the denominators. You can't just mathematically just drop them without actually, like there actually is math behind this. I'll show this one time. Since all of our denominators are exactly the same, if we multiply every term, remember you can, with multiplication, with equations, you either have to multiply every term by something, and that'll keep the equation equal, it'll keep it balanced, or you have to multiply one of the terms by something that's equal to 1. Well, in this case, if we multiply every term by 3x squared, so I'm going to distribute this 3x squared to every term. I guess I could have went the other way with that parentheses. What that's going to do is it's going to end up, you see that numerator and denominator factor-wise, we have 3x squared, 3x squared, 3x squared, and 3x squared over 3x squared. Those are all will simplify out. So by multiplying every term by something that's equivalent to 1, or that every term by the exact same thing, 3x squared, what's going to actually happen is the denominators get dropped. So really we could have just been right here. You have x minus 4 plus 1 equals 2x. And now, once we drop the denominator, we can look at how can we solve? Well, the x terms are linear. So we would, when you have a linear expression or equation, we can solve. We can just move all of our x's to one side. So I'd subtract x to keep the x positive. -4 plus 1 is -3, and it equals 2 minus 1x. We have 1x left, or just x. So the x is going to equal -3. Cool, there's our answer. All right, example 2. Oh yeah, the last would be to solve, the step 4 is solve the equation. I did not write that down. And the equation comes from the numerators. All right, so example 2, factor the denominators if possible. Let's look at the denominator. Yep, we can factor this. So the a is 1 in this quadratic, so we do what two numbers multiply to c that add up to b. So that would be -6 and 4. So there's our first denominator, and our second denominator, nothing to factor there, and our third denominator, nothing to factor there. So those are already factored. They're linear binomials. There's no greatest common factor, so that is all we can do. Next step, so I'm going to rewrite what we have. So we factor the denominators. Now we have to get like denominators. So I'm just going to rewrite so then it's a little bit clearer to what we have as denominators in every term and what we don't have. All right. Looking at our denominators, we have an n minus 6, n minus 6. The last denominator does not have an n minus 6 as a factor. So we need to multiply by n minus 6. But by doing that just to the denominator, it changes the value of the problem unless we multiply the numerator by n minus 6, because this is equivalent to 1. So multiplying by 1 doesn't change the value of the problem. But now we have n minus 6 in every denominator. Now I see that there's more to this. We have n plus 4 in the middle doesn't have an n plus 4 middle term. So we need to multiply that by n plus 4. And what you do to the denominator, you have to do to the numerator to keep the equation balanced, equal. All right. Now we have like denominators on every single term. N minus 6, n plus 4, n minus 6, n plus 4, n minus 6, n plus 4. We can just look at our numerators. Now we're just going to drop the denominator. N plus 3 minus 1 times n plus 4 equals 1 times n minus 6. Okay, we need to get rid of the parentheses. And the parentheses really are there because of this minus. You could carry this minus onto the 1 and make it a plus. And it'd be a plus a -1. That'd probably be smartest to do, the best thing. So you don't forget to distribute this -1 into each term. And then 1 distributed in really just becomes n minus 6. Look at our exponents on each variable term, and we all have linear. They're all linear terms or variables. So that means we can solve pretty easily we don't have to use a quadratic formula or anything. So n minus n is simplified. 1n minus 1n is 0. We have 3 minus 4 is -1. We're going to add 6. Those are your like terms. And the 5 equals n. Okay, so example 3. We're going to look at our denominators. X squared plus 4x. Greatest common factor is x. Divide each term by x, you get x plus 4. We have x plus 4 and x plus 4. Those are linear binomials. They cannot be factored. There's no greatest common factor. Now we're going to look at what do we have in common? What don't we? We all have an x plus 4, so that looks great. First denominator has an x. Second one doesn't. Third one doesn't. We need to multiply by x. What you do to the denominator, multiply it by the numerator, because we need to multiply by something that's equivalent to 1. It does not change the value of the problem by multiplying by 1, like 5 times 1 is 5. X times 1 is x. So x over x, that's equivalent to 1. At this point, let's look at what we have as the numerators. So we have 5x minus 25 equals x times x minus 7. That's a binomial, so let's make sure to put that in parentheses. X times 2 is 2x. Okay, let's look at what else we have. We have distributing the x. Now we have, I see a quadratic, that's important. Quadratic is telling us that we are going to have to use a quadratic formula, or we're going to have multiple solutions here. So we're going to need, let's look at our like terms. We have 5x minus 25 equals x squared. Negative 7x plus 2x is a negative 5x. And now I am going to get the x's together, so let's subtract. Let's subtract 5. Subtract 5x. I'm moving every term to the x squared because x squared is positive. It's a positive a. I'm always going to try to keep the leading coefficient, leading term, positive. Much easier to work with if you can keep it positive. So x squared minus 10. Whoa, that's not x squared, sorry. You can either use the quadratic formula here, so your a is 1, your b is negative 10, and your c is 25. I think we can see a pretty easy way to factor, so I'm going to choose factoring. We cannot solve by square roots because we have more than one term with an x in it. But we can do what two numbers multiply to c that add up to b. That's negative 5 and negative 5. At this point, we have factors equal to 0. To solve, we set each factor equal to 0 and solve them. So we get 5, and of course we'll get x equals 5 again for this other equation. And so that tells us we have a multiple of 2. There's 2 of them. But for actual solving, we just say x equals 5. If you want to say x equals 5, but it has a multiple of 2, you certainly can. That's fine. Nothing wrong with that. Thanks for listening.